Okay, so now we're ready to take our common denominators and start adding and subtracting fractions with unlike denominators. Before we talk about unlike denominators, imagine if you had a fraction that had the same denominators, so like denominators. In that case, you will just add across the top. So you'll add the two numerators together and the denominator would stay the same. Let's do a quick example of that because someone asked me a question about that earlier. Okay. So let's say I had 4/9 plus 2/9. Okay, so my denominators are already the same. And what that means is the pieces, the sizes of the pieces in the whole object are the same size. So it means my pizza is cut into 9 pieces. And each of the pieces here are the same size. Okay, so that makes them able to be added together. If I had a piece of pizza that was bigger than the other pieces, then I wouldn't be able to add it together and really know how much I had. Okay, so that's the reason that we want to have common denominators and that we can only add and subtract fractions once we do have common denominators. So here we just add straight across the numerators. That these are the number of pieces that we have. In total we have 6 pieces and this is their size. Their size is 9ths. That means 9 pieces would make a whole. Remember that we said any fraction that has the same numerator and denominator is equal to 1. That proves that 9 pieces equals a whole. Okay, so that's why it's called ninths. 6/9. Now I noticed something about my 6/9 that would bother me. I have to simplify. I know that both of these numbers have a factor in common. So divide by 3, divide by 3. And the only reason I know that is because I know my math facts. So if you don't have your math facts down 100%, get working, guys. Okay. All right, so let's go on to now if our denominators are not the same, then we need to find the common denominator before we can add it together. Okay, so let's go ahead and do number 1. It says, let's see here, number 1, it says 2/9 plus 1/3. Okay, so from my work with least common multiples and common denominators, I know that my common denominator is going to be 9 because both 9 and 3 have a multiple that is 9. Okay, so I will rewrite or rename my fractions. This one I don't need to change anything. It has the same denominator, so it would have the same numerator. This I need to multiply by 3 in order to get the 9 in the denominator. So the numerator must also be multiplied by 3. Now I'm ready to add. Straight across, my number of pieces is 5, and my denominator will stay the same, 5/9. Here you go. Easy peasy. The hardest part of adding fractions with unlike denominators is finding the common denominator and being sure that we rename the fraction correctly. Okay, let's try number 2. It's a little bit different. It has some bigger numbers. Okay, number 2 says 1/7 plus 3/21. That's an interesting number. Okay, so again, just looking at this and knowing my math facts, I know that 21 times 1 is 21. And I also know that 7 times 3 is 21. So I'm going to use 21 as my common denominator. Okay. So again, if the denominator stayed the same, that means that I just multiplied by 1. Right? So it didn't change at all. So it's still going to be 3/21. But over here, I needed to multiply by 3 to get the denominator to be the same. So whatever I do to the denominator, I must do to the numerator. And the reason for that is I need to keep the same value in my fraction. Okay. So now let's add across the top. 3 plus 3 is 6. 6 21sts. And again, because of my math fact knowledge, I know that that is already in simplest form. Can't be divided by 2. Well, they can't both be divided by 2. They can't both be divided by... Oh, I see a mistake. Look, it's a good thing that I went back and checked. They can both be divided by 3. So 6 divided by 3 and 21 divided by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So the final answer would be 2/7. Wow, that one was tricky. Oh, you can't see it. That one was tricky, guys, and that's why it's important to go back and check. Once I started thinking through it, I realized, oh wait, yes, it can be simplified. Okay, so the answer to number 2 would be 2/7. Great work. Very good. So you can continue practicing these on your own now that you see the process. Okay, continue practicing these. I'm going to go ahead and move on to the subtraction page. And we'll go ahead and do this one. It's the exact same process, except we're going to subtract. Okay, so let's try number 1. Again, we'll need to find the common denominators first before we can do anything else. Okay, so 10/12 minus 1/4. Look at those numbers. Do you know your math facts? Can you tell me what the common denominator is going to be? It's going to be 12. Okay, so this fraction will stay the same. This fraction, I needed to multiply that denominator by 3 to get 12. So the numerator has to be the same. I want it to keep its same value. 1 times 3 is 3. Here we go. Now subtract the numerators. 10 minus 3 is 7. 7/12. Remember, this does not get subtracted. We couldn't have a 7 over a 0. We haven't learned about that. That's not what we do here. 12 and 12, the denominator stays the same because the size of the pieces is not changing. Remember that the denominator is telling us what size the pieces are. How many little pieces fit into a whole? These are 12ths, so 12 of these pieces fit into a whole. We're subtracting the number of pieces that we have. 10 minus 3. And this is, in fact, simplified 7/12. Okay, so that would be the correct answer here. All right, I will do one more quickly. Number 2 is going to be very quick. I can already tell by looking at it. Can you tell what I'm thinking right now? 10 and 5 are my denominators. What is going to be my common denominator here? It's going to be 10. Whoops. It's late here, guys. You can see that I'm making several mistakes. If you see a mistake in my video, be sure to let me know. Okay, so times 2 times 2. That's what I did to get this. Does everybody see? Okay, let's go on. We're ready to subtract. 9 minus 6 is 3. 3/10. There it is. Okay, excellent. 3/10 is the correct answer. You can look at the rest of these questions and the rest of these questions here. There are some word problems that are good thinking questions, okay? And if you want to know the answers to these questions, be sure you send me a message and tell me what page you did, and I will upload the answers to the questions for you. Okay? Great job, everyone.